not only hard for a wolf, it's hard for people. And that looks like a really miserable place to walk. I wouldn't want to. This guy's moving really slowly. So that was the idea. Can we monitor the rate of animal use on these features? And we have, using the cameras. And does this reduce predator use on the linear features? Those are the questions we set out to ask. So here's some very initial results, but for humans and wolves, it was a very direct negative effect, like no one's going there. It's not worth it. The deer, though, were okay with it, and they actually used it a bit more. So why is that? We're not sure, but their hooves are the smallest of that grouping. Maybe for them, they're not as threatened by walking through there in terms of breaking a leg or whatever. Or maybe they realize that it's pretty quiet here and those predators don't come around. They kind of like it here. We're not sure. But those are some of the initial findings. And then this one shows, this is just wolves. And the thing that's really neat here is you look on the sort of the pink bars and just look at the boxes there. That's where 90% of your data comes from. A very good use of snow-packed linear features by the wolves in the winter months with snow on the ground. Very good use. Where there's log rollbacks, like you just saw, year-round it drops right off, very low. And then when there's no effect, it's kind of, when there's nothing on there, it's kind of what you'd expect. They don't, if the snow isn't packed down, they don't use it a whole lot. So it's kind of a normal distribution there. So some really good results from that, showing how beneficial the pack roads and cut lines are, and what the log rollback will do for the wolves. So what does all this mean? Not all linear features are the same. Our research team is right now writing up the results, and they found some very interesting results regarding things like 3D seismic, which there's lots of it, but it's very narrow. And the general finding is that it's not that terribly helpful for wolves, but that'll come out in the paper. The season and the snow mechanism is important to wolves, like I just mentioned. Human and wolf use is correlated in space and time, and this has consequences for predator and prey interactions. And that the rollback treatment appears effective across all seasons. So one thing we found, when you step out and try and do something a little bit out of the routine, it's not as easy as you think in terms of getting regulatory approval and stakeholder buy-in, and there's a lot of consultation. And there's a lot of things that maybe you don't realize you have to think of before you go down this path. So it's something as simple as laying your excess trees, whether they're merchantable or not. The fact is, we cut down a lot of trees that nobody wants, and we're trying to find a home for them. So we think this is a good home, even though this will only barely touch our total inventory. There's a lot of concerns about fire and other users and trappers and you name it. So it's a bit of a challenge to get these things done. So it's not anything that's going to be done on a widespread basis. Right now, anyway, there's a lot more things that have to be figured out before we go down that path. So we've got a total of 6 of these sites right now with the log rollback. I don't think there's any doubt that it's effective, but it's more about how do you do this on a large scale, and do you want to do it on a large scale. Moving on to the third one that I wanted to discuss a little bit here was the what's titled "The Nutritional Mechanism Affects the Health of Caribou in the Alberta Oil Sands." This is again a very similar research team led by Jonah and Sam Wasser, and then Phil Matrix, Mark Taper from Montana, there he is, Montana, and Sebastian from the University of Alberta. So this is about the lichen diet component. So one thing to keep in mind here is that there sure is a lot of mechanisms involved with caribou, and this is just one example of what we call a galaxy or a solar system diagram, and you could probably add a few more circles here, but there's so many factors that you have to try and keep in mind and potentially isolate, and it gets pretty complicated really fast, but you just have to focus on what you can manage and deal with. But there's lots there, as you can see, including things like climate change, parasites, insects, and disease, which we often don't think about as much as maybe we should. So, this study was about advancing in inference, and that was that the nutritional condition was impacted by our presence and by the habitat type. So the data set was augmented with additional analyses for diet and the gender, so that they could make sure they were talking about the cows. And then we also started surveying lichen distribution across our study area, because we realized the importance of lichen, and wanted to pursue that a little bit further in terms of mapping it, and ultimately, can we propagate the stuff? So again, here's the data from each pellet that you can collect, and this is the same slide that I showed you earlier, just in a circle, but the key here is that we added the progesterone for this particular study. So this is very much a preliminary results on published data, but there's a good relationship between the glucocorticoids levels and the lichen. So the more lichen, the less glucocorticoids, which is where you want to be. So this is all to do with the recruitment, ultimately the recruitment rate and pregnancy health parameters for those cows. So, and this one, it talks about lichen availability. Again, just don't fuss too much the scales or anything. It's just that it just reinforces the glucocorticoids, progesterone, and lichen diet. Just a little different spin on the earlier slide you saw in terms of percent lichens in diet and how good the ranges are in supplying that. And just really key here is just the lichen is very important, and the more lichen they get, better off they are, healthier pregnancies, and we're going to find out if that affects their recruitment rates. So what does all this mean? We found that diet can have a larger effect on glucocorticoids than previously thought, and this got a lot of people's attention at a caribou conference last February in Port St. John, and there's folks pursuing this a bit more vigorously because of that. We also feel that health and nutritional mechanisms deserve our attention and may interact with other mechanisms such as predation. So this is something that, again, I don't have a lot of detail on where they're going with this because we haven't got the report yet, but that's something that they want to go down that path. There's range level variability on nutritional effect, again, the range quality, and that we should pursue these multiple interacting mechanisms as you saw in the circle diagram. So on the range effects, this is just a map here that shows where the different ranges are. And these are big areas. That's the big message here, is that the far upper left there, Algar, is southwest of Fort McMurray. You travel down Highway 63 and then you go 80 kilometers on seismic lines basically to get out there. The others are between the two highways, but these are big ranges, and they all have different characteristics based on vegetation types and fire history as far as their lichen amounts and quality. And this just illustrates that. There's the three different ranges, and talks about again, the glucocorticoids, progesterone, and lichens based on the range types. So some significant differences in there, and based on, again, going back ultimately to the scat findings, and now refining that. So what? Lichen is very important, so we're looking at a reclamation trial And again, the health and nutritional mechanisms deserve our attention. Range level variability. Did I put that in there twice? Sorry. The main one here is the lichen is important. We're building a trial, and it's called the lichen propagation pilot. So this is our last project that's underway right now, and all the lichen vegetation soils data will be integrated with the scat detection dog monitoring program to help infer the importance of site characteristics to wildlife use patterns and the mechanistic links between lichen abundance and caribou health. So that's quite a statement. The research team has been built for that. There's actually a lichenologist on that team. It's been broken up into 4 phases. And phase 1 is the one where we've just completed, and that was to do with ascertaining the site conditions through identifying site characteristics, such as soil, light, moisture, vegetation, and substrate conditions that support lichen establishment and growth. So we've got a bunch of sites up there we're gathering some good data on as sort of a baseline, and ultimately we want to see if we can't get lichen to grow and find some donor locations and maybe start sprinkling it out there when we're planting our trees or we're going on tours. We've got people crawling all over this landscape doing all sorts of studies. Maybe they need to take a bag of lichen dust with them when they go. I don't know what it'll turn out to, but it's something we're looking at. So, putting it all together, how does this impact us? And this is again specific for caribou, but this is just a map of the critical habitat for royal caribou in Canada. And you can see in Alberta, we're not doing so well. Every single one in Alberta is pink, which means that we're not at the target level for 65% undisturbed habitat, and that we should move towards that. What does that mean? We're not sure. So we're trying to find out what that means. In the meantime, we're doing all this kind of stuff to figure out how we can aid, in this case, focusing on the caribou. We do a lot of stuff about our reclamation, especially for our short-term disturbance, all our linear disturbances, our OSE drill sites, which are tiny half-hectare sites. And now we're really focusing on how to get to that 65%, and how is it calculated, and how can we, work with all the parties involved to get there. So that's a pretty big deal for us. Has huge impact. That's the cover of the document, in case anyone hasn't seen it. Anyway, the caribou issue for oil sands has been calculated to be in the billions of dollars, and not just 1 or 2, but quite a few billions, potential impact to economic development, etc. So, when you look at one of the economic engines of Alberta, and frame it that way, there's some threat there. So, I think certainly a lot more than we have been doing, Albertans need to make some decisions about our socio-ec land use decisions, how we develop our resources, and are people okay with having caribou not there? We have to ask those questions. We're trying to ask them, and that's meant to be a serious question. And there's all sorts of talk about, maybe we'll pen them somewhere and keep them safe until you guys are done, and then we'll put them back. Maybe that can work. I don't know. So there's all those sorts of discussions. But it's interesting because when Aaron talked this morning about birds, I've had a biologist that I work with tell me a number of times he's not too fussed over caribou. He says the one we really need to be worried about for in situ oil and gas is the Canada warbler, because that habitat and that act, like everything about some of these songbirds, potentially has more impact to us than the caribou. So this is when a lot of oil people crawl into the fetal position and start crying or grab a beer or whatever, because how do you manage all this stuff? It's really hard, and you just got to keep plugging away. And we've got seems like too many of them, it seems overwhelming, so just keep working with everybody, hopefully. So to summarize, we're using science to try and understand caribou a bit better. We have a number of projects underway, and we also collaborate with a lot of industry partners. And the federal recovery plan for caribou has potentially large ramifications for our industry and our ability to develop our leases. And with that, this is from our remote camera. That's a bull caribou, and just taken last September 27th at 10:09:33 a.m. and the temperature was 18 degrees out on our lease. So that's the kind of stuff that we get every so often, some real gems from these cameras. And I'll take some questions if there are any. One over there.
Hi, Gary. You said that you tried to get a little bit of more information on what the federal rules meant, especially interpreting what's a linear disturbance and when does it stop being a linear disturbance. Our company tried to get some information and we couldn't get very far. Did you get some clarification on when is a linear disturbance and linear disturbance?
Yeah, so Bob's question is about the federal recovery plan, what constitutes a linear disturbance, and when can we write it off, and this is exactly what we're trying to get some better clarification on. Short answer is we haven't got too far with that. So initially they looked at a Landsat image and it had to show up on a certain scale of photography, and so that was the cutoff. Our question is the buffer that's applied, so there's a 500-meter buffer on either side of a disturbance. So pretty soon your critical habitat that gets written out gets to be very large because of the buffer. So our question is, for example, if we go out on that line and put a bunch of logs down like we saw there, or do some mounding, like some of our pilot projects are doing, and planting trees, and just making it really tough for the wolves to use. That was the big knock on these lines. So if we take that out of the equation, does that erase the buffer? We haven't got an answer. We'd like to get an answer on that, because that's, that would really help us out to know how we can get there for aiming for the 65%.
The log roll back, are you just dropping trees on either side of the line, or are you actually bringing in logs?
We are bringing in logs at great expense because we have them, and it's a good question. So part of this is relationships and a variety of things. So we've got loads and loads of logs waiting to go somewhere. So to get permission to cut down more trees when we got logs a few kilometers away was probably not going to happen. So in this case, we're hauling them in, which proved challenging this year because we could only do one site because the ground was so soft. It didn't freeze essentially. And when you're going on a narrow line and you've got big long logs, it's a bit tough to lay them down nicely, so then you have to cut them shorter, and then it gets complicated and it gets expensive. On our Algar area pilot that we're doing for linear restoration, we are allowed to cut down some trees, and so there's every so often, either skinny little black spruce, they're better than nothing, but sometimes you do that, so it's quite dependent on what your objectives are, what you've got to work with.
Have you looked at using slash logging where you toss the limbs? There's over 600 to 750,000 cubic meters that have been knocked down in that working circle of stat oil. Have you looked? You're at a big expense using merchant timber there. Have you looked at using slash?
We need to look at the whole bigger picture a bit more. Short answer is not that closely, and a lot of the slash, though, limbs and that is really preferred to be spread back on the sites. So we're left with the
From a forestry perspective, it needs to be disposed of, so there's a cost there. So there may be an opportunity
lots of disposal things. There's using finer chips for mixing with drilling waste. There's a whole bunch of different uses, and we're having that conversation, but you have to have the whole conversation, what we're finding. Don't just pick on one item. But in our case, we've got, we're moving into an area with very little virginable timber, but lots of sub-birch. And what are we gonna do with that? Nobody wants it. So, it's a bit of a problem. And I'm not gonna get into the politics about leaving wood at the side of the road and all that. More over here.
Have you guys looked at access through repairs on the linear disturbance through snowmobile traffic?
We haven't looked at that directly because for the most part, in our area, we've got so much activity with vehicles. And, but I know that snowmobiles are definitely a factor, like 1 or 2 sleds is not gonna make a whole highway. But I don't know if anybody, have you watched the $1 Billion Caribou David Suzuki show? He was talking about the caribou herds in national parks, and his position was that the access there for predators was through backcountry skiers packing down snow, and then also snowmobiles, obviously outside the park somewhere, but that snowmobiles have been pegged as a problem in the backcountry. I think that's more in northern BC where there's a lot of use, so that's definitely an issue.
But we also have, through our core caribou areas, we have trappers that are using the same trap line that go into the core caribou area. And is there a correlation between access to those core areas by predators using those trails?
Yeah, good question. I think that might be worth looking at. I can't comment directly on how much the trappers are using it. Is there someone from Summit Land who can comment on that?
No comment.
Okay. Molly?
With your SCAT program that you can tell, where you nail the land, can you break it down into calves, that, competition?
Sorry, break it down into calves for the.
Like, I guess the question I'm looking for is, what was your ratio of females to calf population?
Okay, that information is just being compiled, so we'll have that soon, but we don't have it right now for it. I'm making negative 2 minutes, so thanks.
Well, hi everybody. When Chanel asked me to do this presentation, I thought about a couple of ways that I could do it. And then she told me it was at 2 o'clock in the afternoon, which is about an hour after lunch. And the first thing I was going to do is to give a lecture on ecological land classification. I thought, that's not going to work an hour after lunch. So I thought it would be better just to take you for a tour through the Northwest Territory and show you a few parts of the landscape that most people have never seen. There will be a bit of an introduction, of course, with respect to what ecological classification is all about and why we even did it. And for those of you who have iPads in the room right now and want to look up this stuff, you don't have to wait till the very last slide to find out. You can Google Northwest Territories ecological land classification, or my last name and Northwest Territories and Titan Plains or something like that, and the reports will come up. This was a 9-year project to survey the entire Northwest Territories. It was undertaken because the territorial government felt that the information that they had was inadequate for the management purposes they wanted to apply it to, such as wildlife management, caribou management being one important one, and forest management in the southern part of the Northwest Territories. So they started out small, and we ended up doing the whole thing after 9 years, but it was a stepwise process. As you can imagine, in any endeavor like this, there are a whole lot of people who have to be involved, and I just one person. I was a consultant hired from outside to help them out because I had some experience with ecological line classification. But there were some key people in the government: Bob Decker, Tom Bazosenbrook, in the Northwest Territories government. Charles Carnicott, you may have heard his name. He's world famous permafrost specialist, and he was an advisor on this project. And Tom Chowns used to be a Northwest Territories employee and has taken care of the wildlife section. If you like the reports, and especially the wildlife part, you can thank Tom for that. If you don't like the reports, and especially the first part before the wildlife part, you can get after me for it. So the outline of my talk is I'll review the ecological line classification framework in the Northwest Territories, and then I'm going to talk about how we surveyed over 1.3 million kilometers in 9 years' time, and how we present the information. And I'll give you a pictorial tour of the Northwest Territories, showing you some of the diversity in there. I understand that one of the subjects of your conference was diversity, and also wildlife, and there will be a few wildlife pics in there. And because this is a forestry conference, after all, I'll talk a little bit about tree growth at the very end. So an ecological line classification in Canada is not a new science. It's been going on since the 50s, some might say since 1937, when J.S. Halliday produced Forest Regions of Canada, the first version. And it is a hierarchical classification that integrates a number of things: climate, physiography, and biotic factors in some way. Different people have different approaches. These classifications have been used and are being used and will be used for resource management purposes. So in protected areas management, for example, and wildlife management, forestry, and agriculture. And they have been used to model climate change scenarios, and there is an exercise like that going on right now for Alberta by the University of Alberta, Rick Schneider. So this is a snapshot or a clip of a map from a continental survey. Canada, Mexico, and the United States have combined to produce a classification system that has 4 levels in it. And the level 1 is the highest level of the hierarchy, and level 2, 3, and 4 are nested levels within that. And you can see the arrow. The different colors here indicate different major areas or biomes, and you can see that the little picture over here is all of North America, and this is the area I've clipped out is basically the Northwest Territories. They got to 3 levels in this classification, and we decided to take it to a 4th level to improve the management capabilities of the product. So just to illustrate very briefly ecological line classification, most of you may be familiar with the concept of a biome, which is a global ecosystem. And in Canada, we have 3 subdivisions underneath that: the ecozone, which is a very large area mapped at maybe 1 to 20, 1 to 50 million; the eco-province, which is generally climatically determined, which is mapped at 1 to 10,000; and the eco-region, which is mapped at anywhere from a scale of 1 to 250,000 to 1 to 5 million. The eco-province is 1 to 10 million, not 1 to 10,000. And the equivalent on the Northwest Territories side, underneath the classification system we devised, which I won't go into in a great detail, but you can read about it in the reports. The level 1 is the biome, basically. So there's 3 in the Northwest Territories. There's the tundra, which is treeless. There's a taiga, which is the land of little sticks, basically, is what it converts into. And the Northwest Forested Mountain, which extends all the way down to California and just touches the Northwest Territories in the very southwest corner. In the level 2, for example, if we take part of the level 1 in the taiga, there's a mountain system called the Taiga Cordillera, which is defined by regional physiography, and that would include geology and landforms. And in the level 3, beneath that, there is a climatic subdivision of the Taiga Cordillera called the Cordillera High Subarctic, which is it's defined by various features, and I'll get into that a little bit. And the level 4 ecoregions are the finest subdivisions, which are the management units. And this one would include, within the Taiga Cordillera, high subarctic, this would be the northern backbone ranges, a very dry and high range of mountains in the north part. So there's 5 major level 2 ecoregions in the Northwest Territories, and starting from the top, the northern Arctic. I don't know if you can see the arrow here. The northern Arctic is treeless, and so are the tundra plains and the tundra shield. These 2 blue units here, they're essentially treeless. The Taiga Shield is characterized largely by shield rock and very open to closed forests. The Taiga Plains is characterized by a lot of wetlands. That's this band that runs up the center, and that the last presenter showed had a pretty good caribou habitat that was in good shape. And the Cordillera is over on the side here, and it's constituted of comprised of mountain ranges. We can subdivide these 5 units climatically into subunits, and we can do it by using existing models such as these ones produced by Agriculture Canada. The left one showing the range of the relative decrease in precipitation as you go from south to north. This is also a pattern in Alberta, by the way. And the relative decrease in temperature as you go from south to north, which is also a pattern in Alberta, as I'm sure is no surprise to anybody who's worked in the grasslands and then gone up to the boreal subarctic. Now, because there's so few climate stations up there, those models were based on only a few permanent stations, and so we need to find some other way of assessing climate and its expression. And so we use permafrost features and we use vegetation features. So, for example, in the very northern part, we use these purple saxifrage barrens. Purple saxifrage is a cushion plant about a centimeter tall, and it's all that can grow up there. And as we get farther south, we can use these peat polygons to help us delineate the line between high subarctic and low subarctic. And then further down, we can use jack pine to help us delineate the line between the low subarctic and the high subarctic. And then as we go farther to the west, there are plants that have crept up from the south, lodgepole pine and alpine fir being 2 of the most obvious ones that help us delineate the line between the milder boreal cordillera climates and the slightly less mild high boreal or low subarctic cordillera climates. So that's what happens when we use all of that information together. We end up with a number of different climatic units. There are 9 units in all, and I can't obviously describe all of them in any kind of detail here, but to illustrate, the high Arctic oceanic is the very coldest places in the Northwest Territories and probably in Canada. These areas are subject to unstopped wind blowing from across the Arctic ice cap. It's very dry. The precipitation there is far less in the dry grasslands here. As we move further south, we pass the low Arctic, which is slightly milder, but by no means tropical. And then into the high subarctic, which is characterized by sparse conifer woodlands and continuous permafrost. And then we move into the low subarctic, where the permafrost may not be so extensive anymore, and conifer forests tend to be more closed. And then down in the very southern parts, in this area down here, which is called the Banana Belt of the Northwest Territories, and you'll see some pictures of that later, we have conifer mixed with deciduous and discontinuous permafrost. So within those level 3, we also subdivide the area into level 4, and you can see, if you can see on your screen, on the screens, there are very faint gray lines right around in here. My arrow is right above the words Taiga Plains right now. There's very faint arrows in there, or gray lines, and if you look at the little cutout box, that shows you the level 4 ecoregion. So these are based on vegetation and local physiography. So these are mapped at a scale of about 1 to half a million. So what did we do? The methods were fairly consistent, and they had to be throughout the 9-year period of this project. We had focused and extensive field programs to collect the information. We had a good assistance in GIS mapping. And then we had, of course, to prepare the reports that captured all of this information. So the classification and mapping concepts are defined in section 1 of every one of the reports. They're all pretty much defined the same, but the tail grew in the telling as we went on through the 9 years, of course. So our explanations got a little bit more detailed as they could as we went along. You have to have a consistent and explicit approach to something like this, otherwise the framework itself is not consistent and explicit, and it is not of much value for management if that's not the case. So the entire Northwest Territories was done under one philosophy, and that philosophy was carried through all of the reports. So the field program, we had to do some provisional mapping ahead of time, of course, to figure out, well, where is the climate, where are the level 3 and level 4 units going to be? What should we plan to fly through? When you're planning up there, you really need to take stock of your fuel supply and the distance your aircraft can fly. You have to take stock of weather, which is extremely variable up there, and you can't count on anything. There's other hazards like smoke and fire and so on, and all of that has to be taken into account, so you really need to know where you're going at the beginning of the day. We ended up flying 125,000 kilometers plus for this project in fixed wing and helicopters, and not always in the best of weather and not always in smooth air either. So gravel was a constant companion during those days when convective activity was high. And most of our field work, the convective activity was high in the southern part because July is the month for field work down there, and thunderstorms are around a lot. So we collected over 70,000 oblique aerial images and 10,000 ground images over a 9-year period, and I personally looked at all of those images at least 4 more times during the process of producing the report, so I'm surprised that I have the eyesight left. These are the aerial transects that we actually did. The different colors stand for different years, and every one of those lines is a part of a transect, so we got pretty complete coverage of the entire Northwest Territories through that 125,000 kilometers of flight we conducted. And so that you know, each of those lines is actually a series of dots. At each dot, a photograph was taken and an observation was taken. The observations, we actually wrote down something about what we were seeing at the time so that we would have something to refer to in the future with respect to what the heck the photo meant and why we even took it. We had a direction on the photo, and it's geographically referenced. So this information is publicly available, and you can call it up, and I'll give you the address at the end of the presentation. We had about 200 ground stops during the course of the study, which were very focused. I picked an area which I thought was representative of the landscape as a whole, landed there, and we took a lot of photos and made some site observations, and then extended that information to a much larger area. This is all you can do up there because obviously conducting a field program over a 9-year period, which is very intensive, isn't going to work too well, or is going to be difficult to implement given what I mentioned in terms of fuel and access and so on and so forth. We also had a few other plots to work with from previous researchers. I mentioned what we used this information for in terms of climate. And this is some of the ways we use that thematic information. So all of these dots that you see there, for example, for jackpine, this is where we noted the occurrence of jackpine, and it helped us delineate the climate areas based on the intensity of transect information that we had. So we're pretty confident that where we put the lines is where they are today. And I have to emphasize that any report on ecological classification is a benchmark of where we're at today, because this may change. Some things are constant, like geology is fairly constant, but climate will change, and I'm not going to say why it changes. I don't want to get into that discussion, but we do know that climate does change, and it always does. So it's a benchmark for what we have at this point. And all the photos we took are also benchmarks. They have a date on them, they have a place on them, and you can go back to that place and sometime in the future and take another oblique and assess what's happened to the landscape. So we had to integrate all this information. This is the long part. So we took the worksheet. We had several workshops, 10 or 11 in the course of the study, where we used expert opinion in combination with the information we got from the field, digital elevation models, hydrology, Landsat, and so on, all the information we could get for geology and peatlands distribution, all the information that we could get for climate and vegetation, and the wildlife information was particularly valuable for, of course, the wildlife section of the report. And so we structured the report, and again, we started it in 2005, and we continued a consistent format thereafter. So we always discussed the concepts at the beginning, then the methods of how we did the study and what information we used. Describe the ecoregions, describe the wildlife, which is admittedly where most people go to right off the bat when they start with these reports. They go to the wildlife section because the rest of it is kind of boring time. But there's a lot of nice pictures in the wildlife section, and the appendices to support it all. So this is what a picture of the ecoregion descriptions looks like. It's not very much like the Alberta report, but it does contain some of the same sorts of information. You'll see the same headings. But I decided I would present it in this format so that it would appeal to both the technical user. The stuff on the left-hand side of the page is the technical user. The stuff on the right-hand side of the page gives an overview of the ecoregion without having to actually read very much text except for the captions on the photos. So it gives you an idea of what it looks like and what it would look like if you went there. And the birds and mammals are handled the same way. Lots of pictures and some descriptive text. And there's published in digital maps for each of these ecoregions and posters that you can get your hands on. The current uses: modeling forest growth, modeling protected areas, species at risk management. They've been used to revise the national classification. And for general education, kids use them in schools. I have a friend who's got grade 5 kids who really think some of the, especially the wildlife section, is pretty neat. And they also provide background information for EIs and CEAs. So I'm going to give you a short tour now. Start from the northern Arctic, which is an area that's mysterious to most of us. It certainly was to me, and I had no idea what I was going to encounter before I got up there. So the northern Arctic consists of basically islands north of McClure Strait, which are the McClure Strait being at the bottom of the little square here. And so there's Melville Island, Prince Patrick Island, Mackenzie King Island, Borden Island, and Brock Island and Borden Island. This picture here is taken from Brock Island, the very tip of Borden Island, the most northerly part of the Northwest Territories. You might think these are icebergs, but that would be impossible because there's no source of icebergs. This is actually multi-year pack ice. Multi-year pack ice surrounds these islands up here all year. It never melts. At least it hasn't so far. At least in the 30 years that the radar images have been taken. This is this purple saxifrage I referenced in an earlier slide. It is planted maybe a centimeter across. The flowers on it are mostly on the south side, which is where the heat is. These plants make use of a very low stature to avoid the wind and to take advantage of any ground heating that occurs. There are no plants up here that are taller than 2 or 3 centimeters, and those grow in sheltered places. Poppies will grow on better quality soils in sheltered places and put their flower heads up a few centimeters, but basically there's not even any shrubs up there. The prairie caribou is a common animal up there, although they're not very numerous. And there are a few ice fields here and there. I'm just touching on the high points. There's a lot more to say about the Northern Islands and this, but those are the high points. If we go south of McClure Strait to Banks Island on the left and Victoria Island on the right, they have a very interesting glacial and geologic history. Victoria Island is one of the largest volcanic deposits in Canada. The snow geese and Banks Island Bird Sanctuary are a fairly well-known feature on the west coast of Banks Island. Mountain avens is a very common plant of the tundra, lending a gray-green appearance to it, and it flowers for a few weeks in July, and by August, the growing season is basically over up there. The lower right image there shows tree-sized willows and a muskox about 1.5 meters tall at the shoulder. This is a very unusual feature. You would think that trees could grow up there if they were introduced, because this particular valley has a combination of geology and aspect and so on that makes it several degrees warmer than anything to the south for a few hundred kilometers. So you will see as we go along that the Northwest Territories is actually a very diverse landscape. If you look at the southern Arctic now, along the west coast of the southern Arctic, pingos are a very common feature, and they are more numerous here than anywhere else in Canada. The lower left image shows an example of patterned ground or permafrost. These are low center polygons and are produced by frost action in an area of continuous permafrost. The image on the upper right is a barren ground caribou, and I managed to get in front of a herd that was slowly walking along, and they surrounded me like a forest for a time until I took this picture, and then I was standing in a river of caribou that moved incredibly fast from one place that I was standing to 5 or 6 miles away in a period, I swear, of maybe 10 minutes. And then the barren ground grizzly to the lower right is an iconic symbol of that part of the country, and this one had 3 cubs. In the Cordillera, there are 3 major units. There's the tundra at the very north part, and then there's the taiga and the boreal Cordillera in the south. The tundra and taiga Cordillera, the lower left image, shows the Richardson Mountains. It's a very almost, it's a treeless place, and just tundra grows there. And it's considered to be almost, well, part of it was unglaciated for almost 3 million years. It's part of Beringia. If any of you have heard of Beringia, that takes up a large part of the Yukon as well. Open woodlands in the upper right, left-hand image are characteristic of the high subarctic and the tough climates that occur there. But there are some fairly productive valleys in the Tiger Cordillera. These moose, there were 5 of them in the place that the valley that I landed. This was early August, and they were, fortunately for me, not too aggressive because I was only from here to the center of the room away from them. And anyway, that was impressive to see. I didn't expect, nor did any of us expect to see animals that large in a Cordilleran valley, but it just goes to show that there is productivity in that landscape. The lower right image is the Franklin Mountains, this long spine of mountains that stretches south and north of east of the Mackenzie Mountains, the Mackenzie River, and it contains some elements of high subarctic landscapes that you don't see in too many places like sordid circles. The boreal ecosystems south of this red line here include some areas that are much better forested and have more diverse vegetation, and some spectacular landscapes. The one on the upper right is on the Grand Plateau. This area probably wasn't glaciated for 300,000 years. And when we were there, we found fossils lying all over the place, and a very, very deeply dissected landscape where river channels cut straight down through limestone like this, leaving valleys like this that are perhaps 10 or 15 meters wide in places. Dull sheep habitat is abundant there. In dull sheep-like areas where there isn't too much snow, they do extend all the way up into the tundra Cordillera and the Tiger Cordillera as well. And the upper left is a colonial community, a small crumbled stand of subalpine fir. And this is a species that generally occurs in the mountains to the south and to the west. So it occurs in Alaska, it occurs in the Yukon, it occurs in Alberta, and it occurs in British Columbia. But it doesn't occur it doesn't occur north of the red line at all in the Northwest Territories. It and other species that are characteristic of milder, snowier subalpine and alpine climates occur here. And it corresponds to an area here of the highest precipitation in the territories. If we went back to the earlier slide showing that, you would see that this is the wettest place in the Northwest Territories. The lower left image is part of a group of mountains called the Cirque of the Unclimbables. People do come from all around the world. It's now part of the national parks. As of 3 years ago. It became part of the national parks, and it includes granite spires that are the remnants of a vast Mesozoic dome of granite and of magma that melted its way up through overlying sediments. The area around it is called a skarn, and it's metamorphized rock. And in that area are a lot of hydrothermically deposited minerals, which are valuable. So there's some pretty high-grade zinc deposits and other kinds of metal deposits in the area. The Taiga Shield, this green area to the lower right, is characterized. I'll just go over the major climatic variants in here. So we've got the high subarctic in the yellow area, and it's characterized by oak and spruce woodlands. The low subarctic, the brownish tan area, is characterized by very huge burns and a lot of bouldery till. Not nice country to try to walk around in. The lower left image characterizes the high boreal areas of lots of ponds. There's lots and lots of ponds in the Taiga Shield. Lots of ponds and lakes. That's characteristic of it. In the lower left is the mixed wood forests. Taiga Plains, the Mackenzie Delta, the high subarctic is in the upper left image. The upper right image is these peak plateaus I was referencing earlier, and they are permafrost features. The grayish white areas are actually black spruce and lichen and moss stands with Labrador tea. And the areas that are brownish are areas where the permafrost is melted out. This is a very dynamic system, so permafrost can reform in some of these areas that permafrost is melted out, and subsidence can take place in the areas that are currently vegetated by black spruce. The lower right image is a pitcher plant, which is rare in Alberta and was formerly thought to be rare in the territories, but it's merely uncommon now because we found it in several places. The lower left image is this banana belt I was talking about, very productive, lush forests along the Liard River. So I'm going to talk at the conclusion here about tree growth, and I'll talk at the outset about climatic controls of tree growth, and then I'll talk a little bit about local site controls so that you can get an idea of how it works up there. But we probably all know that tree line is a climate indicator of temperatures, and especially temperatures during the growing season, because it's important to have a long enough growing season to allow epidermis to form on the needles of conifers so that they can survive the winter without desiccation. Generally, this means that the temperatures have to be greater than 10 degrees Celsius for trees to survive. And we did I took some observations when I was out there on tree line in the Cordillera to get some idea of how slope aspect and latitude and longitude might influence tree growth. And here are the consequences. You can see that there are a number of different sized spots in the Cordillera, which is the pink area. And the largest spots indicate the tree lines that are the highest, and the smallest spots indicate the tree lines that are the lowest. So you can see visually that there is a trend from north to south and east to west. East to west less so, or west to east less so. Of a decline in tree line from north to south, and a similar decline from west to east. And this can be partly explained by climate, because we have seen that there were climate variations from, say, the boreal down here, which is at the lowest end here, which is an extension, a northern extension of those mountains that go all the way down to California. And then as we moved up, it got colder and drier. And as we moved away from the border between the Northwest Territories and the Yukon, it gets drier because the mountains have a rain shadow effect. This all influences tree growth. And what I did to collect this information was basically to hover in a helicopter at tree level and take a GPS reading and a photograph at that place. After collecting about 88 observations, I came up with a formula assuming a linear relationship that says that there is a relationship and it's a negative relationship between latitude, longitude, and elevation. So the adjusted R square value was 0.38, which isn't great, but it does indicate that about 38% of an assumed linear relationship between elevation, latitude, and longitude is there. So what's the other 70 or 62%? Well, we can assume that it has to do with site. I only use south-facing slopes because the north-facing slopes, on the few observations that I did, have showed that aspect really had a strong influence. They, in the same valley, a south-facing slope and a north-facing slope would have a difference in tree line of maybe 1 to 200 meters. So with respect to site and climate controls, again returning to the banana belt, we see here a tree that is about 30 meters tall, balsam poplar, and over 30 centimeters in diameter. So this is some of the best aspen growth that I've seen, even in northern Alberta. Aspen growth is comparable to that area. And the reason for it down here is that both climate and alluvial soils contribute to the growth. So these soils are rich, they're moist, and the climate is warm, relatively speaking. In this area down here, you know, if you, on an average day, if you look at the Fort Liard temperature, say on a day like today, it might be +2. Whereas the northern Arctic that I showed you before, climate stations that record automatically up there are still showing -20. So there's a big difference between the south part of the Northwest Territories and the north part, to be sure. And the vegetation certainly shows that up. So here's an example of climate again, and also nutrients, and the proximity to flowing water. So on the left-hand image, you can see a very dense stand of shrubbery underneath a stand of very spire-like conifers. So the coniferous growth in the south part down by Liard tends to be, I mean, the crowns tend to be much larger. These crowns are pretty narrow, and that shows the influence of the harsher climate in the high subarctic, which is you know, on the same latitude as Inuvik, and I think everybody has an idea about how cold Inuvik can be. But if you go a little farther north there to Aklavik, and you get off the floodplain and you get into areas that are not commonly flooded, the effects of continuous permafrost then become evident, because the trees there are a lot shorter and they're a lot older. So some of these trees here were 250 years old, and maybe you know, they were a few meters tall, versus these trees here, which might have been less than 100 years old and tens of meters tall. And then we also have just the effective aspect. This is the same hill, this is the same esker. So I'm standing here on the north-facing side of an esker at the base of a tree which is 5 meters tall and over 200 years old. But only a few meters away on the south-facing slope, I'm standing at the base of trees that are 9 to 11 meters tall and only 110 years old. So the effects of aspect here are obvious. So the south-facing slopes warming up faster in the spring, protected somewhat from the cold blast of the winter winds, which tend to abrade the needles from the base of the north-facing slope. So there's an example of where we have climate, which is very cold up here, but still allows trees and patches to occur. Notice again the narrow spires, and the trees at the very limit of their ability to survive. So if you do want to find the reports, maps, and photos on the web, you can use those search terms, the ones that I mentioned at the beginning. There's also a very nicely put together spatial data viewer that you can look at almost all of the photographs that we took up there. So admittedly,